Thank you again for the warm welcome, warm introduction. So I edited my slides so that you can see new things, so that you don't get bored. I added new videos and things like that. Okay. So today I'm going to talk about a very, very interesting topic, how we can make robotics more affordable so that everyone can own a robot. Why? Let me play this video. So, yeah. Stop it. Yeah. So, who doesn't want a robot at home to help with daily work like cooking or cleaning? Let me ask this question again. How many of you here dislike cooking? I'm one of them, right? I don't like cooking at all. So, I would love to have a robot to help me cooking, cleaning, or doing some chores and bringing chocolates from the fridge at night and something like that. So now the problem is, or the biggest question is like, can I afford it? Being a student, definitely I cannot. That's where the real problem begins. Before moving forward, we should we need to understand what we mean by smart robots. A smart robot is not just a machine that moves. It's it's one that can sense, think, act on its own. To do this, it needs powerful hardware like precision motors, accurate sensor, and especially GPUs or processor that can run complex AI algorithm slash models. So the smarter we want the robot to be, the more powerful and expensive the hardware becomes. And that leads to three major problems today, which are hurdle for scalability. First, high cost of hardware needed to run large AI models. Lacking perfection, that means industry is running toward making a generalized model, foundation model that can do every task instead of focusing on one and making one perfect. Tell me one thing. If there is a robot in your lab and you're working side by side, and the robot itself is generalized, running a general policy, and you know for sure that okay, this can go wrong anytime. Will you feel safe? Not at all. I won't. And if there is a model who whose task is very specific or specialized and it's working with you side by side, so you'll feel more safe with that. So I would say I prefer to make the approach here I'm telling is about making models perfect on specialized task instead of generalization. And of course, we know that there are high energy demands when we run and train the model as being, and especially very large AI systems. So for let's put this slides is on y-axis. There is parameters of the AI model, and sorry, in on x-axis there are parameters of the model, and y-axis is CO2 emission. It's a carbon footprint, and you can see there is some sort of interpolation that we can make from this graph, that the higher the number of parameters are there in the model, the higher carbon footprint will we get. So we can conclude that it's not at all good for environment as for the environment, right? So moving forward, this I have added these video. Yeah. So let me mute it. So these challenges led me to main research question. How can we build a scalable approach to AI embodiment in robotics? How can task-specific AI models deliver efficiency, that means lightweight, optimized for single task, practicality, that means real-world usability at a much lower cost. You don't want to like use GPU credits for $50,000 and make the robot just move a pen. And scalability, that means modular deployment across industry. My goal is to show that smaller specialized AI models can make robotics affordable, efficient, and sustainable. Let me walk you through an example about task-specific AI model I'm envisioning right now. It can be a washer, cleaner, mopper, chef, or guard. And as I mentioned already, the principle here I'm following or I'm coining out again is perfection over generalization. These models will be on demand, lightweight, cloud based, which means the robot doesn't need to carry heavy compute hardware. The solution I'm proposing is Model Zoo. Similar to App Store, you want to make your robot washing dishes perfectly, click washer. It won't break your utensils for sure. If you want a robot that should clean your car, click cleaner, download. Just like you download apps in your phone, you can download models on your robot. So this proposed solution will help on reducing the complexity of model because the parameters will be less. The hardware requirement will be less because the parameters is less again. And it enable flexibility. You click it, it will be downloaded from the cloud, making it more affordable. And and this is one of the project that I was part of. And here you can see the robot is folding cloth. I just added this video so that, yeah. So let's talk about benefits and impacts. This approach offers several benefits like cost saving. Robot won't need expensive onboard computers. Sustainability, energy use and carbon footprint will grow. Scalability. Robot can be offered as robotics as service, plug and play models for industries, and the most important, democratization of robotics, especially for small businesses, students, startups, teachers, everything will be like not only dependent on high-end GPUs, but you can bring your ideas into reality with available resources also. To conclude, to summarize, I would say task-specific AI makes robotics affordable and sustainable. Lightweight model reduces both cost and energy need, and cloud-based model deployment allow flexible and support green AI practices. Let's walk through an example. Suppose you are on a trip to somewhere and your robot is at your home, and while coming back, you want them to cook for you. You can just on app turn on your robot and download the chef mode, and your meal should be prepared by the time you come back home. This approach will allow robotics to move from large industries to home and small businesses like the smartphones once did. A future scope. In future, I plan to develop a train grid, an in-house decentralized training grid. It's just like Uber for GPUs. Suppose I have a GPU in my home that I'm not using while I'm in the office. While I'm working for someone else, my GPU can work for me. So that it will allow us to train smaller AI models efficiently without needing expensive centralized servers from AWS or big uh, NVIDIA GPUs. This will make training faster, cheaper, and more eco-friendly, pushing robotics into the next level. I'm open to questions now, and you can contact me on LinkedIn. I really love to say this, but you can Google me as Ankit Kumar, Columbia University, and I'll be the first popping on your Google search. Thank you.
Ankit, thank you. I pronounced your name wrong the last
Perfect.
time, but um, we have a couple questions so far. What new service offerings could emerge from the widespread availability of affordable task-specific AI robots, especially in industries that were previously cost prohibited for extensive automation?
Can you repeat the question? It's a long question.
Yeah, that was a long, long question. What new service offerings could emerge from the widespread availability of affordable task-specific AI robotics, especially in industries where previously cost prohibited for extensive automation? So let's break it down into two questions, right? What's new service offerings could emerge from widespread availability of affordable task-specific AI robots? So if you could
Yeah, sure.
order a robot, what task could you do for new service offerings?
Yeah, for a new service offering, Um, Let me think about it. Uh, hmm. Yeah, so I would say new offerings that can be made is like some specific task, like fixing a car, that can be done by robot. It's not a very risky job in terms of robot, even if it touches something or hits something. So some services like, your car is being fixed by your robot, and other specialized service, because who makes the most money is specialized people in today's industry. Someone is very specialized in robotics AI embodiment, they are earning very high, a high amount of like salary. Why? Because they are specialized. It's analogous to that. Our specific models can be used in specific jobs that are dangerous to human. Not only like it's not about only intelligence, it's also about dangerous. If someone needs to sail a boat and it's not a good weather, I would prefer sending a robot rather than a human if it's ultra urgent. So those kind of thing where we can find a fine line between safety for human, not only promoting taking jobs for human, but also promoting safety for humans. Yeah. I hope this answered your question.
So you would trust I just want to clarify. You would trust a robot over a human?
No, I'm saying like if there is a condition where we have to ask, where we have to send a human, suppose cleaning nuclear plant or something like that, we can send a robot to save human life in that aspect.
Oh, like okay, cleaning a nuclear. Okay, yes,
Yeah.
okay. Um, and then the other half of that question was where industries were previously cost prohibited for those extensive automations. So what about other, I guess, industries that I don't know how to, I guess it was too costly maybe for them to have automation?
This is more domain knowledge question, I would say. So I'll need an example to elaborate on that, honestly, because I haven't thought this much about it, like specific industry where there is a barrier to it. So I'll be honest.
Can someone said, can we have a future RoboCop in the future?
Yes, that's my dream. I want to
Well,
uh,
RoboCop
change.
wasn't a cop; he was a cyborg.
Yeah, I want to put my consciousness into a robot.
He wasn't a robot; he was a cyborg. So
Yeah.
those are two different things. Um,
A funny
yeah,
story is like why I started robotics is because I loved my dog so much that I wanted to uh like put her consciousness into a robot so that she can live forever.
I will say, just going on a tangent, they are using like brain tissue into computer bits now, so to help with the thinking process. But next
Yeah.
question, how efficient can a robot be to perform the tasks like cooking, folding laundry compared to humans? I think that this is what will make the difference as robotics and AI advances. I saw robotic doing tasks like kicking a football or taking and serving popcorn, so it is definitely promising to see how it develops. So basically how efficient would a robot do doing normal household tasks basically?
Yeah, so for answering this question, let's go back few years ago, like 5 years ago, 2021, there was no robot who were folding clothes, right? There were no robots, there was no chat GPT and nothing. And we have seen a trend of increasing the tech very speedy in a very speedy way, right? So I think right now the efficiency seems low, but it's promising for the future. So within 5 years or 10 years, you can see robots that can cook for you and that can do things that even human cannot. So just look it as a graph of time versus the development cycle, and it's y equal to mx plus c, where m is 45 degrees. So it's very steep.
Yeah, I have two questions from Lucky. one from the previous session, right? What do you think is the biggest barrier to making robotics affordable for everyday use?
The biggest barrier is hardware as well as software. When I talk about hardware, not only GPUs, we all know that GPUs are a problem, but even actuators are very expensive. So that is one problem. And on the software side, we are limited by the GPU's memories that can be comprised in a very small runnable environment. For example, if you train a model for physical intelligence is like 2, 2 billion parameters or something like that. You cannot run it, inference it basically, or run it on a real robot until you have at least 5060 Ti. So that's a barrier right now. But I feel like while moving forward, everything will be solved as we progress. So within 5 years, you might see robot everywhere.
Nice. And then Lucky also asked how much consciousness can be transferred from human to a non-human entity, considering the amount of trillions of terabytes of data a biological brain holds.
Um, I believe right now you cannot the researchers are going where yeah people are talking and results are promising, but current state of art says that it's very limited. But think about it, every time you chat with chat gpt, you're putting some of your thoughts into it. So somehow chat gpt is also started to have some consciousness of you in its model. So sometime I daydream and I talk to ChatGPT. Hey, suppose I bought a stock for $2 million and it's increased by 10,000 times. How much richer I will get? So this is another conscious questions and desire that I have, right? And that's what I'm putting in ChatGPT and it's training on that. And coming back to the real question, yeah, not right. There is limited information right now, but in future, as quantum computer starts kicking, I think everything will pan out and start give us promising results.
Right, because Microsoft and Google have their own quantum computer chips.
Yep,
Yeah.
true.
Um, how do you think of safety concerns and potential regulations on these affordable applications when mass adoption is taking place?
Yeah, so we have also seen a trend in government regulations. Suppose Europe has started some, I'm not good with remembering the names, but the policies has been included from Europe side. Data privacy and different regulations are been there. And US government has also proposed some regulations as these robots are getting into public places and things like that. They are basically recording, right, when they are seeing the environment. So there are strong policies that are kicking in. But again, like policies are there, but data breaches happens. So we should be aware that whatever we are sharing with the robot should be limited to a point where it can't affect. Because no matter how, we have been in the software era for last 50 years or something more, but we have seen these data breaches happening everywhere. So there would be breaches for sure, but that's why we should be always conscious of what we are sharing with the robot or with ChatGPT and things like that.
And then while we're on that topic, what safety mitigation plan would you have in your mind?
Of course, if I have a robot that's cooking and doing everything for me, he'll have a corner in my house where he cannot facing towards the wall when he's switched off. Making sure I'm not changing things or changing clothes in front of my robot and things like that. That's particularly the case. And even if there are robots, like because it's a converging thing. We are just getting used to robots surrounding us, right? We don't believe it. Just like cars. When cars came, people were afraid, like, okay, there is cars coming. They might lose control, they might do accident and things like that. But with time, with 50, 60, 70 years, they'll become integral and important part of our lives. So it's in short, it will take time to make comfortable us comfortable. But of course, some mitigations I would like to take is like when it's needed, it's working, like in the kitchen or cleaning. else it's off. Off means power off and like no on mode or something like that. So that it's not listening to me, not recording my videos and things like that.
Awesome. How do you feel about vibe hacking a robotic?
What do you mean by vibe hacking? I
Oh,
have
you haven't
heard
heard
the
that term? It's people use like different codings from like Claude or whatever to hack systems.
so yeah, I have used these some of these models. The problem is in robotics, they are not very good. So there is still a very big gap between robotics. I have to do the system architecture and tell them like this is wrong or this is what's wrong or right. So there is a issue, but I think someday you'll see ChatGPT version which will be conscious in life and he'll be talking to us. He is talking, but he can control different peripheral devices.
Awesome.